Hello friends, today we will discuss Python NumPy libraries. It provides fast arrays which are like Python arrays but they store elements in a continuous memory location. That's why NumPy arrays are much faster than Python arrays. We use NumPy arrays to perform operation on huge dataset, and they are widely used in AI and ML projects. Let's see how we can define a NumPy array. First, we need to import the NumPy library, and then we can define an array as np.array, and we can specify a list of values. It will create array1 and we can apply different functions available in the NumPy library. NumPy array can store only one type of elements, but it provides a lot of data types. Like for integer, it provides int 8, 16, 32 and 64. We can use it as per our requirement. For unsigned, it has uint 8, 16, 32 and 64. For floating, complex, bool for boolean, string for string. We can specify data type while creating an array, or we can create array without data type. In that case, since a system will infer data type itself. Here we can see we are defining the array and providing our data type int16. If we print what is the data type of nums, system will print int16. Sometimes it is required to convert one data type into another data type. We can use asType function for it. Value array is defined as the array of floating points 1.8, 2.4, 9.7, and floating point takes more memory space. And as per our use case, we only need integer. So we can write vals.asType int. It will create an array with int data type. If we want to print the values, we can see it is 1, 2 or 9, all floating points gone. And if we print the data type of as int, it is int 32. We can perform different arithmetic operations on the NumPy arrays, and it is very simple. Let's say we have two arrays, A with 5, 10, 15 value, B as 2, 4, 6 values. And we want to add the elements like 5 plus 2, 7, 10 plus 4, 14, 15 plus 6, 21. We can simply write A plus B. It will add the elements of A to the elements of B and perform sum operation. Similarly, we can do subtraction, multiplication, division, and other operations. We can find out what is the shape of an array. NumPy provides three different functions. First is shape. Let's see X NumPy array, which has two dimensions 10, 20, 30, 40, 50, 60. So if you want to print the shape, we can say x.shape and it will print 2, 3. If we want to find out what is the dimension of x, then we can say ndim. Shape will print, okay, 2, 3, whereas dimension will print, okay, it is two-dimensional array. And size, it will count the total elements and print it. We can perform different Boolean and stats operation on NumPy array. For example, if we say mean, so it will find the mean of all the value defined in the num. Similarly, standard deviation, sum, min, and max. It's very easy. Just use the predefined function from the library and pass the array. Rest, NumPy will handle it. If we want to operate Boolean operation, we can say nums greater than 10, then it will check this condition on each element and print values. Sometimes it is required to reshape the array. We can see X is a single dimension array, but if we want to make it two dimension, we can simply say reshape and we can provide the dimension, and this array will be reshaped accordingly. We can see it here. If you want to transpose it, then we can use r.t. T means transpose. If we want to revert it back to single dimension, we can use flatten method. It will convert multi-dimensional array into a single dimensional array. We can concatenate two different NumPy arrays into a single array, or we can split them. Like A and B, these are two arrays. If we use concatenate operation, both will be merged and converted into a single array. If we want to split it, we will use np.split and we can provide 2. So this array will be converted into two different arrays. Sorting and search. Sorting is very easy, just we need to use sort. Define an array and say sort, it will be sorted. If we want to search a particular item, we can say where and provide the condition. Based on the condition, it will return all matching attributes. Indexing is similar to Python, where each element has index starting from 0. If we see this array, so first element index is 0, 1, 2, and so on. We can print the element by providing the index. If we provide 0, it will print the first element. If we say 1, it will print the second element. We can also provide index from the end. In that case, we will say -1, -2, and so on. If we say -1, the last element will be printed. We can print a range of elements by providing the range. For example, we say 1:5, so it will print the element with index 1 up to 4. The end index is not included. So 1, 5 means 0, 1, it will print 20, 30, 40, 50. If we want to print the elements by stepping, so we can provide after double column. Double column 2 means it will print the first element, then leave second element and print third element. So it will print the element by stepping 2 every time. NumPy also provide universal functions, or we can call them U-funcs, like square root, log, sin. It's similar to other functions. Just provide the function name and pass the array. Copy and view. This is very important. Copy means create a copy of all the elements into a different memory location. Whereas view means just have another pointer to the same location. View doesn't replicate the data, and if we change any element, then the view will also change. Whereas if we copy, then it will create a new array and the values will be different. If we modify the source array, it will not impact the copy one. Let's see it. There is an array which 3 value 369. We are creating a view V. So view means pointing to the same location. And then we are also creating a copy C. It means we will copy all the elements to different location. Now we are changing the first element to 100. So what will happen? Since view is pointed to same location, the values in the view will also change. But the value of C will not change. We can see here value of A is 169, value of V is automatically changed because both A and V point to same memory location. Whereas the C, it maintains the original data. Thank guys. If you like this video, don't forget to subscribe it.